So guys, in the last class we had completed till the effective length. You can see here effective length equals 0.85 EL, and we got answer 1963.5 meter, sorry, mm. Okay, so now we'll continue with this. So now since so we got, so we'll write today's date. Today's date is, it's 14 10 20. Okay, 14 10 20. So now slenderness ratio slenderness ratio is equal to L effective length by R minimum. So effective length is, so we can round it up here. So 1963.5 divided by R minimum is, you got it from the steel table, 30.5. So you get lambda is equals 64.37. For an angle, buckling class is equal to how much? We have done this already in the last semester. Buckling class, C, page 44, and hence refer 9C, page 42. So for this buckling class C you can get from page 44, and from page 42 you can get the, for this 9, for C 9C table you can get, you can check out. For 60 it is 180, 168. For 70 it is 152. Therefore for 64.37 is equal to how much? So therefore FCD actual, you get it around about 161.8 Newton per mm square. 161.008 Newton per mm square. So therefore load carried by member P actual is equal to area actual into FCD actual. So area actual is whatever you have seen it from steel table, 161.008. So 612.84 kilonewton, which is greater than 360 kilonewton. So hence safe. So the designed member can take the load 612, and the load presently on that member is 360. Hence the design is safe. So your top chord is over. So now connections for your top chord. So connections. In shear, VDSB is equal to VNSB by gamma MB. So VNSB is equal to what? It's FUB by root 3 NNAN plus NSAS. So now your top chords are like this. So in middle there is gusset plate. So if I want to put a bolt, two shearing planes will come into picture. So I take directly Nn equals 2, Ns equals 0. So you can write down bolt is made up of full thread. So therefore Nn equals 2. I'll take. Assume dia of bolt is equal to 20 mm. So D naught becomes 2 mm extra. So 22 mm. So I got Nn. So what is An now? So this turns to 0. An is equal to 0.878 into pi into 20 square by 4, that is equal to 141. Sorry. So therefore VNSB is equal to 500 divided by root 3 into 2 into 0.78 into pi by 4, this. So you get answer 1417.6.35 Newton. So 141.47 kilonewton. So therefore VDSB is equal to VNSB by gamma MB. 141.47 divided by 1.25, that is equal to 110.8 kilonewton. So now in shear over, now in bearing. In bearing, VDPB is equal to VNPB by gamma MB. Okay. So we'll continue up with the same date, 14/10/20. So what is VNSB? We have solved all this. VNPB is equal to 2.5 kb dtFU. So where kb is equal to E by 3d naught, P by 3d naught minus 0.25, FUB by FU and 1. So now you can select E is equal to 1.7 times d naught and 2.5 times. So 1.7 times d, 2.5 times d. So if you do this, so you get answer 1 is 34, approximately equals to 35. So this you get it as 50 mm. So substituting all the values, so approximately they have made it up to 40 here. 34 is made it to 40. Okay. E 40 by 3, 22. 50 by 3 into 22 minus 0.25. FUB is 500 because 5.6 grade bolt, 410 and 1. So 0.60, 0.50, 1.21 and 1. So KB is least of all the. So therefore VNPB is equal to 2.5, 0.5, 20, 10 into 410. So I get 102.5 kilonewton. So therefore VDPB is equal to VNPB by gamma MB, that is 102.5 divided by 1.25, that is equal to 82 kilonewton. So bolt value BV is equal to least of both this and the it's least between this and this 82. So therefore number of bolts is equal to bolt value by force by bolt value. So force on this is 360 by 82 kilonewton, that is equal to 4.39 bolts. So round it up to 5 bolts. Okay, then we'll see the design of bottom chord in the next class. Thank you.